So thank you for coming here. My name is Sadayuki Furuhashi. I'm a co-founder of a company called Treasure Data. So 4 years ago, I moved from Japan to Mountain View and founded a Silicon Valley company. And we also open sourced this product called Fluentd. So I will talk about this. So let's start from very beginning. Here's a high-level analytics system architecture. So of course, you need to collect data from servers, mobile devices, or even smartwatches. Then store that to somewhere. That's the very start point to start the data analytics. Then process that data using some tools. There are many tools like Hive, Presto, R, that kind of things. Then visualize the data. Then create some reports so that you can decide something or improve your system. This is very basic infrastructure. And these days, especially in these 3 or 4 years, I think, there are many tools created here for storage and processing. Hadoop is one of the biggest things, and you now have Spark. You also have Presto. And to store data, you can use HDFS, Amazon S3, or Google Cloud Storage System. It's very good. For visualization, in fact, Excel is one of the best tools to visualize the data. Then now you have some other BI tools such as Tableau. You can also use the machine learning system there, or you can use R to visualize the data using those algorithms. So now the total time from the beginning to get the results is shortened a lot, thanks for those technologies. However, if we focus on this data collection, it's still a problem, I think. That's somewhere Fluentd focuses on. So Fluentd solves the data collections problem. So for example, data collection problem is like this. You have applications, and you need to collect data from those applications and store that to HDFS or somewhere. And each applications have different log formats or different column, different type. And you need to set up something for those applications, one by one. And it's a very painful work. Even if you set up once, application changes. So you need to keep maintaining the scripts. And if the application changes or the script is broken and data is not collected appropriately, the visualized results will be broken. So you cannot trust the results. So data collection, having a reliable data collection, the stable data collection is very basic thing, essential thing to make the results trustable. So for about the data collection, maybe this was 3 years ago solution. Application servers have files locally. They use log rotation and create files every hour. Then set up our thing, SCP, that kind of thing, to collect data to our storage, central storage. That will be like HDFS, NFS, FTPS, FTP, whatever. But here, a big problem was that this latency is so high. You need to wait for a completion of one file and completion of the data transfer between the network. It's high latency. And during the data transfer, the network bandwidth is consumed a lot. So it could cause some problems. It could cause some problems on your production environment. And even if the data is collected on the storage, it's still a file. So you need to parse the file. But the parsing is hard. You need to prepare correct parsing logic there. And the parsing itself also takes time. You will run MapReach job or Hive queries to parse the data, but still it takes like an hour or even more. So before starting data analytics, you have this latency. So you cannot use the fresh data. You can't analyze the data in real-time way. So it's a problem. So to solve this problem, you might think about this architecture, or you are doing this architecture. Create a script for each combination of the inputs and outputs. For example, if you have Apache Web Server and Nginx Web Server, you create a tool which tells the log and forwards the data to Hadoop. Okay, we even have Elasticsearch hosted on Amazon. Okay, create another scripts to send data to Elasticsearch. Okay, we want to join data with data coming from mobile devices. You create another logging script. Okay, I want to join with Twitter stream so that we can do more advanced data analytics. Create another script here. But this is very painful because you need to maintain n multiplied by n scripts. So number of scripts increases a lot as you want to do more advanced, accurate data analytics. And those scripts need to handle the common data collection problems, which is retrying or the handling broken records or handling the duplicated records or buffering, retrying, that kind of things. And let's say someone created this script and unfortunately he leaves the company and you need to take over that script. It's a nightmare. I won't do that. Well, I did do that several times, but it's not good. So the true solution is this, I think. So have a central hub to collect everything first. This is the unified logging infrastructure. Then set up this to forward the logs to the outputs. With this way, you don't have to manage n by n scripts. What you need is n inputs plus n outputs. So it's much more scalable. And if you see this picture, I think you will think about that how Kafka is different from this architecture, right? In fact, the last session here by Pinterest suggested very good learning. So yes, Kafka can be here, by the way. But they also built a tool called Singer, right? So it handles the log parsing, and it has plugin architecture to parse the application logs. It also handles the at least one mechanism. It means it has buffering locally and retrying. It also has handling for data duplication. It also has filtering in it. And when you want to copy the data from Kafka to S3, you also create some other tools. That's something presented before today, right? So question was maybe, do I need to create Singer again for our system? It's not, because Fluentd solves the problem. Fluentd is an open source project you can use right now. So let's go into the Fluentd internal architecture. So Fluentd is a plugin-based architecture. So this is a bit simplified architecture diagram because there are some more plugins around it. Parser plugin, format plugin. But this is a bit basic architecture. So there are input plugins, filter plugins, buffer plugins, and output plugins. So logs here are all structured like that. So log has a time and a tag, which means this log comes from which data sources. And it has also a body, which is JSON format. And this time is the time when the log generated. It's not the time when the log is received. This time is very important later. And you will set a tag for each inputs. So this log comes from web application, this web application. This log comes from system stats. This log comes from mobile devices. You set tag for each data sources. And then body is JSON. This is not text. So here's one important principle of Fluentd. You should parse logs first before storing them. That's because applications know about the data structure. That should be applications' responsibility to format the log so that data analytics can start immediately. So Fluentd uses JSON for the entire system. So the data is now structured. It has JSON body, tag, and time. And using those events, you can route the messages to appropriate plugins. For example, this log coming from MySQL goes to this filter plugin. Then convert the data or enrich the data. Then goes to buffer plugin. This buffer plugin is responsible to make the performance better or make sure the data is correctly sent, including retrying and at least once mechanism. Then finally goes to the output. Okay, then here's some more details about input first. So input receives logs, or input plugin can pull data from external services periodically. So one example is in HTTP input plugin. It receives on a port and accepts data from web browsers or others. So one use case is that a user. So this input plugin receives data or pulls data from other data sources. Yeah, and one use case is HTTP input plugin. So one user uses runs Fluentd instance on EC2. They have a lot of servers there, and put a JavaScript web beacon on web pages. Then every time user accesses to the web server, the JavaScript logs data to this Fluentd input plugin. Then you can program the Fluentd internal to route the events to appropriate the output. The another input plugin is tailing plugin. It reads data from a growing file. Let's say you have nginx and the nginx logs data to a file. You don't have to change nginx at all. Instead, Fluentd reads the data automatically and parses the logs. And syslog is another plugin, of course, and you can receive data from other instances. And important here is that input plugin should be non-blocking. So in log aggregation system, we need to think about the load of the network and storage. They could be unstable depending on the traffic or the system status. But even that time, we need to make sure data is stored eventually. Otherwise, the following analytics steps will be unreliable. We cannot trust the data. We make sure that result is always trustable. So Fluentd first receives the data anyway, even if the network is unstable or the storage is overloaded. It doesn't block. It means that even if the logging system is unstable, it doesn't affect the applications. Of course, applications should be the first priority. Logging is the next. Even if logging is down, application should be running correctly. So input is non-blocking. It's an important point for data logging. Then events goes to filter plugins. Filter plugin transforms logs or filter out unnecessary logs or enrich the data. So one plugin often used is data encryption plugin. So you have data including like password or healthcare information. You don't want to store that somehow. Then you can apply this plugin to encrypt the data. But at the later step, you can still decrypt the data because that's an encryption. Or another way is to apply a hash function. The data is anonymized by this filter plugin, but still you can tell this is same with this. Then this is most likely acceptable for data analytics, data statistics. But still, at the same time, you can satisfy the security requirement. So a filter plugin can do that. Another big use case is to convert IP to regional information like countries or areas. This is also important for the data analytics. And you don't have to do that on the later data analytics step. I think often cases you do this conversion at the later ETL steps, but filter plugin can do that in streaming way, in real time. Another use case is parsing the user agent. So this is Firefox, this is Chrome, that kind of thing. This can filter, this can convert the user agent information to the browser type, OS type, that kind of thing. Combination of those is also very important because let's say you don't want to store the access logs of bots. You apply a filter plugin to parse user agent first. Then apply another filter plugin that removes accesses from bots. So you can use multiple filter plugins and enrich the data. And then data goes to a buffer plugin. The buffer plugin is for performance and reliability and multi-threading performance. There are two types of buffer plugins right now. One is called memory plugin, and the other is called file plugin. So this stores data in memory or file. And memory is, of course, faster. But if you use memory, it becomes harder to operate the system. It makes it difficult to restore the system or apply new code to the system. So then file is more reliable. It's slightly slower, but the performance difference is almost like 10% or so, because in most of the cases, data is in file cache. So reading data and writing data is done in memory by kernel, Linux kernel. The overhead is just calling system call, write system call, read system call, that's it. So it's reliable and fast. Then things go to output plugins. The output plugin just send data to somewhere. Important point here is, I think, customization. You have many number of storages, I think, depending on the use cases. Now you have search engines, data analytics systems, and of course you also have PostgreSQL, MySQL. You want to sync those data using output plugin. You can plug in output plugins. One output plugin is file, one plugin is S3, another is MongoDB, and there are hundreds of plugins released as open source. You can fork those open source projects to create another plugin. Or of course you can create from scratch. So it's plugin-based system. So in those plugin architecture, important thing is extensibility, customizability, so that Fluentd can handle the direct integration to your application to the logging system. And but this buffer plugin is a bit different. This doesn't handle the integration of application logic. Instead, this handles the reliability. But in fact, this is one of the most important components in Fluentd. So Fluentd uses this buffer architecture. A buffer has chunks in it. One chunk stores several logs in it. And input plugins write data to the latest chunk. And output plugins read data from the oldest chunk. It's queued up. So this means that even if output is blocked or not working well, input can still write data to the latest chunk. And time passes like 10 seconds or so, you can configure, or size of a chunk exceeds certain threshold, like 10 megabytes, it creates a new chunk. Then it's queued up. Then output is done by chunk basis. So it's more like batch. So if you write data one by one, row by row basis, it's slow. But because Fluentd takes care of this buffering, it's much more faster. And more important thing is that it's scalable. So if input is faster than the output throughput, it's a problem, of course, because this queue grows and grows. But the traffic is not consistent every time. Traffic can have peak time and idling time. Then buffer takes care of the leveling of the traffic. When the traffic is high, it queues up, and the size of a chunk becomes bigger. Then output writes the big chunks to to the output at the maximum throughput. Then if the traffic becomes idling, chunk size will be smaller. Then it's more real time. You can flash data every second or every 2 seconds or so. So this plugin is for buffer plugins for performance and reliability. This is also important for the network transfer, distributed system. So if you think about the batch-oriented, this kind of data transfer, it needs to retry from the beginning if a problem happens. Let's say there's a network problem, it needs to retry from the beginning. And there's a broken data somehow, then you need to retry from the beginning. Then sending all data takes long time. But because Fluentd divides the data into chunks, the impact on the error is small. So you can make the logging system more reliable. And let's say there's a broken data you cannot send or the storage cannot store. In that case, Fluentd has a feature called secondary, so that if output gives up storing the data, you can move the data to another storage. Let's say somehow Elasticsearch cannot store data for 1 hour. Then Fluentd's secondary plugin stores the data to S3. It's a fallback path. You can recover it later. So it's chunk by chunk basis. So buffering is a very important feature here. So let's go into some more specific examples. One is this, very typical. So you have web server and writes data to access log file. And in most of the cases, you have some customization there. The log is not common Apache format, but has some extra headers in there at the end. Then you use tail plugin with some other customization here and configuration here. Fluentd tails the data as it grows. And Fluentd writes data to buffer chunks. And if you use file buffer, the data buffer chunks are persistent on a disk. Then use output plugin to write data to Elasticsearch or other storages. And here, again, if this is unstable, Fluentd retries the sending. It guarantees at least once. Yeah, of course, it has exponential weight so that it doesn't cause too much problems. And then when you think about log file collection, tailing from a log file, you need to take care of the log rotation. It's actually a tricky problem. Apache writes data to a file, but if a size of this file exceeds a certain threshold, Apache will create a new file. Then all file will be moved to another file. Fluentd also takes care of this problem. But in fact, if you write a script to do this, it's tricky. So Fluentd creates a file called postfile. Postfile stores the last location of the file so that the next polling can read from that position. And it also stores the inode number of the file. So Fluentd can detect the log rotation by checking the inode difference. Then, so Intel plugin takes care of that problem. And also, you can plug in those parser plugins. Here, I used Apache as the example, but there are plugins for Apache error logs, or JSON format, CSV format, TSV format. What's this log? This is also a very common use case. You have application here, something here, buffer data, and route the events to multiple locations. It's very common. You have recent data on Elasticsearch, Splunk, those search engines, so that you can look up recent data very quickly. But on the other hand, it's hard to scale those systems. Or perhaps you need to pay more to scale the system. But you don't need all data on those search engines. What you need is recent data only. So you can use Fluentd to configure the system. Fluentd has a copying plugin to send data to multiple locations. It's a sort of meta output plugin. So there's an output plugin called copy. So it receives data first. Then that meta output plugin writes data to other output plugins, multiple times. And Fluentd also supports log forwarding. So you have edge web servers, hundreds of web servers first. Then you can aggregate those logs into aggregation servers. Then at this point, what you need to care is the reliability of the aggregation servers. You need to think about load balancing and HA and failover. This Fluentd plugin called outforward takes care of it. If this output plugin keeps sending the heartbeat between other Fluentd instances, then if it detects a failure of a server, it forwards data to another Fluentd instances. And if you store data on HDFS and process the data using Hive, this partitioning is also important. Hive often assumes data is partitioned by hour or by day, so that you don't have to read all data every time. But the problem here is that it needs to be guaranteed that this file doesn't include logs from the other hours. Otherwise, the result will be broken, or that you need to read more files to guarantee that all data is in a file. So here, Fluentd uses the time when log generated, log produced, to partition those files. Even if the log forwarding delays, it guarantees the logs are in the file with the produced time. So you can immediately set up the partitioning on the data collected from the Fluentd. So you can immediately start the data analytics here. If you use S3 instead of as a replacement of HDFS, same thing. S3 plugin also slices the files by the hour. And as I explained, that's plugin architecture, and it's open source product. There are 3 or 4 core developers, including me, coming from several companies. And they are a pretty big development community for the Fluentd core. And there are much larger community for creating plugins. There are hundreds of plugins released on the web. One user wanted to integrate with DeskCom. They wanted to collect data from DeskCom and store the data to a search engine so that they can search the tickets easily. Another person wanted to collect data from Kafka. And there are many use cases for each user, and all of them are released as plugins, so you can install it. Output is the same. One user wanted to put the data to Zabbix because they have Zabbix there. And if you think about, okay, we have this system, we want to integrate the logs with using Fluentd. You can search on the Fluentd website. There's a list of plugins released. Probably that's already there. You can find one. Even if you cannot find, you can customize those existing ones and create a new plugin based on that. So you almost don't have to create from scratch. So there are some real-world use cases, more high-level use cases. So one user collects data from mobile or web servers, and that is AddLocks, add impression logs. They store data to Teradata, which is cloud-based data processing service. And then they have hundreds of servers here, and aggregates the data to tens of servers, then send data to Teradata. And point here is that because this is HA supported and buffering supported, and at least once is guaranteed by Fluentd, they didn't have to write code there. Yes, this is also very common use case. Hot data goes to search engine, and cold data goes to HDFS as archive. This is an example configuration. So here, you have source, match. Those two, source and match, There are two major configurations. Source describes the input. Here you have two inputs. One is tail, tailing from a file. Here's post file, which records the last position. And the format is Apache, and you can also customize here to write a regexp. And tag the data with this name, web.access. Then you can match with this tag to forward the logs to somewhere, or filter the data using filter plugins. Here we use copy plugin, and write the data to two locations. One is Elasticsearch, and one is HDFS. Here's another source. This receives data from other Fluentd instances, or you can use client libraries, like client library for Ruby, client library for Python, client library for Java, to send data directly to Fluentd. And streaming data processing is another major thing. So there's a, well, so first of all, there's a product called Esper. Do you know about Esper? Maybe not. Okay, it's actually a historical old product, mature, very mature product. It can run SQL on top of the streaming data. It's Java, it's Java product, and one company backs the product. Noricura is an integration between Fluentd and Esper, which means that you can apply SQL to the streaming data. This is for many purposes. For example, you want to detect anomaly from the web access. Then you can apply one SQL to process the data. And if the SQL finds something weird, it puts data back to Fluentd. And use another plugin to send email, to send notification to Zabbix, or send notification to SQS. That kind of integration will be in Fluentd. And here's another thing. Docker container can send data directly to Fluentd. So in fact, if you install Docker, it comes with Fluentd logging module bundled in it. When you start Docker with command line, you can specify the output location. And you can say Fluentd colon space, the local host, blah, 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 to send logs to Fluentd. Then you can aggregate those data to some aggregation servers and send data to those services using the integration plugins. And some giants, enterprise companies are using Fluentd internally. So this is one example. So Microsoft is using Fluentd for their log collection. So I think Microsoft is changing recently, I think. Microsoft had a log collection system for Windows. Of course, it makes sense. But they needed to create log collection for Linux or other open source middleware. Then they choose Fluentd as the infrastructure. So internally, they use Fluentd and package it as OMS agent. Then they distribute this product to their customers. So they said that having hundreds of existing plugins helps them a lot. So here's Atlassian, a company behind Confluence and Jira, and Hipster Bitbucket. So this is a very good example. They use Kinesis to control the flow of the logs, but still install Fluentd on those edge servers to take care of the at least once and log parsing problems and the buffering problems. Of course, you can think Kafka instead of Kinesis. They are very similar system. So this combination helped them. And Amazon Web Services also uses Fluentd and recommend it to their users. It's actually documented on Amazon. So I think, in terms of technology, I think this is good technology. And this is one of the most successful projects I started. But, and it's used for those big companies. And one deployment is 200,000 servers. All of them deploy Fluentd. It means one of the biggest computing cluster in the world deploys Fluentd to the old servers. So I think it's proven technology, but unfortunately, it's not so well known right now. It's a problem. So I think Fluentd is not only for those big users, but this is for everyone. So at the last, I want to say that please let your friends know about this Fluentd at this weekend. How good it is, how good it looks like, maybe. And another thing is that, so Treasure Data as a company supports this Fluentd project. We are the biggest supporter of the Fluentd project. And we are looking for sort of evangelist to let people know about Fluentd. I think technology is good, but people don't know about that. So please contact us if you are interested in the evangelism work with a good salary. So, okay, that's it. Thank you very much. I think we can have some questions.
I have a question on your buffer chunking. You said, based on the traffic, you resize the chunks. So do you use any prediction algorithm, or what's the model you use behind that?
It's based on, the size of a chunk is based on your configuration. They're not smart algorithms, in fact. It's based on size or time, which are either the first satisfied. So if
predetermined. Is that a predetermined?
Yes, it is predetermined. You need to configure it, actually. By the way, do you have some suggestions to?
I was thinking maybe, can it be a dynamic, because I cannot be knowing when the traffic is coming, or maybe there is a spike or something.
Right.
How do you regulate those?
I see. So typical configuration is that make the maximum limit large. So you can buffer at the most 4 gigabytes, as long as disk is there. And make the buffer size small. And make the time long. It's basic configuration, and it works mostly well.
Right, so I had a question about basically buffering data helps, like throughput. But on the other hand, you want, data to be available to the, downstream sources as fast as available. So, if you keep uploading new files to S3, that's going to, for example, lead in a lot of files. So you might need some, compaction process or something. Right. Does Fluentd support, compaction out of the box? No, it's
actually a very difficult problem. So, so one architecture people do is that use one plugin with short flash interval to send data to real-time search, like Elasticsearch Splunk, and use longer flash interval to send data to S3. This is for archiving. So having copy plugin and different buffer setting mostly solves the problem. Well, in fact, another solution is that we provide data analytics as a service. So you can sign up and send data, and we do the compaction.
Someone else?
So do you do any data format transformation type of thing? Just
data format to parse the data or store
you're getting unified NOC layouts, so you're getting all kinds of different NOC, and then do you do anything on top of that, or just store and flash to S3?
I see, yes. So yeah, data format is, I think, 2 locations. One is output side, and the other is input side. And for output side, yes, there are plugins, in fact. I simplified the architecture. There's input and output, but in fact, there are formatter plugin next to the output plugin. So you can plug in the formatter plugins to use your format. And input is the same. There are parser plugins to parse many other formats. And internally, it uses, well, we say it's JSON. It's schema-less data format, but actually it's MessagePack. It's binary efficient format.